Okay, I want to thank everybody for coming tonight. I mean, it's a little late, and I'm tree lines, some other tree line folks here as well. I want to thank Capital Factory for letting us be here. Our drink sponsor is Draft. Jason, say something.
Yeah, I'd love to. Thanks, Earl.
Thank you.
Yeah, we've sponsored the Node.JS meetup a couple times, primarily because our platform is developed on Node.js. Mike McNeil and the Treeline folks were part of it early on in our early days, and they did a tremendous job. I want to tell you guys a little bit about Draft, but before I even do that, the main thing is if we are looking for some hardcore developers right now. We are a recently funded company here in Austin, and we need developers bad. So write this email address down. I don't have enough cards, so jason@draftapp.com. If you aren't happy with where you're working now or aren't working now and are a Node.js developer, please reach out to us so we can talk to you. And there's a good chance we are going to be hiring 2 to 3 people over the next month or so. So please reach out to us. Why do you want to work for us? We are a unbelievable new startup here in Austin that deals in fintech, which is a very hot market right now. We do investment analysis across people's holistic portfolios. And what we do is really novel in that we take your holistic portfolio and we compare you against the top 10% across returns, asset allocation, and fees. We're getting tremendous feedback from the industry and from users. We have a growing wait list. We're in private beta right now, so you're going to get in on the ground floor. We're approaching 9,000 people on our wait list. We're also working with big banks like USAA, Citibank. It's a really exciting time to join our company. If you're interested in fintech or just a hardcore Node.js developer, please reach out to us because we want to hire you. So thank you guys for sponsoring or for hosting this, and we're proud to be a sponsor. So enjoy it, guys.
Amen. Thank you very much for the beer. If you can't find a seat, let me know. We've got some extra chairs.
Can I say, is Luke Keith here? He's one of our front-end developers. He should be here later. I'm going to have to jet out early, but if you have questions about Draft or anything, Luke and Keith will be here, and Mike. These guys know the platform. I'm the non-tech guy for the team, so but Mike and all the Treeline guys know the architecture pretty well too. So, but I'm going to have to jump out.
Got a bunch of background jobs.
I also want to thank our food sponsor, Spanning. I think Mike, you want to come up and say a few words.
So tell you a little bit about Spanning. Spanish Products. We do backup for SaaS-based applications, which by itself seems pretty boring, but the reality is what we really do is highly scalable apps to process a couple of billion records a day. We support products like Salesforce, Google Apps, Microsoft Office. We're currently between offices right now. Here in Capital Factory in the 5th floor, we've got 50-something employees. Polyglot stack, so we've got Java for some of our apps, made a big push to Node.js about a year ago. And we got some monolithic development, we got some microservices development there, and like everybody else, we're hiring. We're not going to beat that horse. Anyway.
Thank you, man. Thank you for giving us all this great food. Before I introduce Cody, I just want to reach out to everyone here. If you've got someone that you'd like to hear speak, if you'd like to speak, if you've got an idea for a topic, please don't hesitate to email me on the meetup. We want to make sure that what we're producing for y'all is what you want, and the only way to do that is really, y'all got to let us know. All right, so Cody. Cody is one of the core developers of Sales. He is the creator of Waterline, and right now he's a core developer of Treeline. So we're really excited to have him here and talk about async world, so let's go.
All right. Can everybody hear me? All right. So just quick, like, hand raise. I know everybody hates to do this, but how many people have like worked with Ruby or Python or like a synchronous language where you have background jobs? All right. So good chunky. All right. So again, thanks for the sponsors. This is Capital Factory, Draft, and Spanning. A little about me. Earl said I'm Particle Banana on the interwebs. I'm the co-founder of Treeline and a Sales.js core team member. And I mainly work on the ORM for sales called Waterline.
So what's behind the Twitter handle?
It's a word generator, generates 2 words and places them together, and nobody else had it, so.
Better stories.
And it sounded cool. I have actually a banana painting in my apartment, so I just kind of. All right, so today we're going to talk about background jobs and what they are, how to create them, when to use them. If you're coming from other languages like Ruby and stuff, you've probably used them or written them before. It's actually built into the latest version of Rails Active Job, so it's like a core part of the framework. In Node, background jobs work a little bit different, or at least they appear to. Being asynchronous has its benefits, and it also confuses a lot of people about what should be done in a background process and what can be done in your actual like web request. There's callbacks, so you can have timing issues and stuff like that. So we're going to kind of go through some of that and kind of see what's different about it. So we'll start with an easy question: what is a background job? So we have a normal request response lifecycle. So a browser hits a URL, in this case foo/bar. That URL does some stuff and returns a request. Pretty simple. So if we extend that out and we have something that's going to take a while, so we have the same browser, it's going to hit foo/bar, it's going to go and do some stuff, and we have a really slow function that's going to sit here and spin and spin and spin, and eventually return your response. So nobody wants that to slow. Like, your API should be fast, shouldn't sit there and spin. So what we want to get to is something like this. You have a browser, hits a URL, does some stuff, and then simultaneously sends off a job, does some stuff in a different process, but returns immediately. So when we talk about background job, that's what we're talking about. Something that runs on a separate process, independent of the actual request response lifecycle. So the first thing you hear when you start talking about background jobs is, this isn't Ruby, this is Node. It's async, we don't need background jobs. We have callbacks, right? So let's break that down a little bit. The main reason people talk about that is because Node doesn't block. And so you hear this word blocking a lot. It's used all the time in JavaScript and Node. And it comes from this concept of blocking the event loop, which we'll touch on in a little bit. But let's see what blocking means at a high level, right? So traditionally you have a server, you have 2 browsers. The browser's gonna hit the server is going to do some stuff. Meanwhile, browser 2 comes in and can't do anything, right? It's stuck. So in other languages, you have this concept of threads where you end up with a bunch of web servers in different threads. You usually put it behind something like Nginx or Apache. I had this funny thing. It's like going to Chipotle and ordering your burrito, except your burrito can't be started until the other person has completely gone through the line, finished, paid. They forget they want the grilled veggies, so they have to go back, put the grilled veggies on it, and then they can start yours, right? So that's what we mean when we say blocking. It's blocking the actual server from doing anything else. So with Node, you have these browsers, you have a server. Browser 1 hits the server, goes and does something. Meanwhile, browser 2 and browser 3 hit, it's not blocking, queues it up. This is like going to Chipotle, ordering your burrito, you put your order in a bucket, so everybody puts their order in a bucket, the order or the worker pulls out a thing, starts making your sandwich. You can still only make one sandwich at a time, but you're not blocking the other orders from coming in. So that's what they say when they say non-blocking, right? So this is what we want to get rid of. We want to turn this slow function and run it in a different process. So how can we handle that? callbacks, right? So callbacks are the most common async pattern in JavaScript. So let's see what a callback looks like. You know, this is something that if you've written JavaScript, you've seen 100 times. You do some stuff. In this case, we have A and B, sum them together, and then we have something that takes a long time. So this thing that takes a long time, it's got this function here that it passes in. So it's going to run the long task, and then it's going to call this function when it's done. Right? So this isn't ideal for background tasks, right? We aren't blocking the event server because we're using this thing called the callback, right? So our server can keep responding. But it's the same thing. We have to wait until the process is done before we can respond to our request. So we still have that same pattern of the function sitting down there. We do something, we have this really long function, and then we can return the request. Just at the same time, that server can also accept other requests. So another way, we can just ignore the callback. And it's actually rare that you can do this in a language. It's pretty cool that you can do this in Node, right? You can just fire a call or fire a function and just completely ignore its return value and do something else. So that gets us to this, where the browser hits a URL, does some stuff. You have the slow function, but we can return at the same time. So that looks something like this, right? We do some stuff, we sum A and B, except this time we run the long task and just completely ignore the results of it, right? So we can just, that's gonna hit this long task and it's gonna return immediately. We don't want that, right? The client gets the data back, but we have absolutely no idea if that function, errored out, what happened. We have no idea what happened. Either does the client. We can't send a result of that back down to the client. So that's a good solution if you absolutely don't care about the results. So if you're debugging something, if you're logging something, if you're starting or stopping a timer, it's fine. But for anything like sending emails or something like that, it's not a good solution. It's also not running in a separate process, so it's not what I would consider a background job. Right? So a background job, remember, is something that it's going to run in a different process, and it's not going to prevent it's not going to stop the response from returning. So we could also over-engineer something completely over-engineer, something related to process spawning, where if you use Node, you have this thing called child processes that you can spawn up, and then you can have some communication. It's not worth it because it's still only going to run on a single process. So we're not even going to go into that. There's some people on the internet that have done some really cool stuff with that, though. So what's the answer? Right? We don't need to reinvent the wheel. We just look to Ruby and Python and all these other things that have done it, and it's remote queue. So just like Ruby, moving work to remote queue not only takes cycles off of your web processes, but it allows us to handle processing of these long-running tasks intelligently. So remote queues are something that hold work to be done, and they can be done at a later time, right? So that looks something like this. You have a browser, you have a server, you have your queue, and then you have a worker. So a browser is going to hit the server is going to do some stuff, it's going to queue up a job, and then return. So that gets us to that thing we're looking for, where it's not blocking the request, and we get something that can be run in a separate process. Meanwhile, our worker is going to grab that job off the queue, it's going to go ahead and process that slow function, and it's going to be done. So what that gives us observability. We can see our queue, we can see exactly how many items are in the queue, we can see how long they're taking to process. We can scale that out horizontally. So if our queue is taking too long, we have too many items, we can scale it out and add more workers to process more things. And our queue can be preserved, so no jobs are abandoned. If you're sending an email and you're doing it in your web process and your web process crashes, that email never gets sent. There's also no way you can ever go back and send that email because you have no idea that it needed to be done, right? So this is better than a simple spawn process. And most job queues also give us some cool features like retry. So if you're hitting an API or something and your network connection doesn't work or something fails, you can retry that. Or if something's rate limited, you can set your jobs to be rate limited too. So you're not overflowing like an API or something like that, like GitHub or something. So a scalable remote queue is going to look something like this. Right? We have a load balancer usually, and we have a web server that's processing our API request or a web request. We have a queue, which is just a database, and we have a worker. So it's taking a lot of requests, so we need to scale out. So we add a server and we add a worker, and we just doubled our capacity, right? We didn't have to change any of our code, and we just doubled our capacity. So we start getting more traffic. We add more servers. We start getting more jobs. We can add workers, we can scale down workers, we can add all this stuff, and now we have this completely horizontal scalable infrastructure. Okay. So that's the basics of what a background job is. But in order to understand when you need a background job and when you can do something in line, we got to talk about the event loop a little bit, right? So we have a basic understanding about how to build these background jobs, but in order to really get into it, you have to understand how the event loop works. And that's a pretty complicated thing. We're not going to go too far into it, but we're going to touch a little bit on how things move in the single-threaded architecture. So here's a simple web server in Node. We require the HTTP library. We create a little request handler. In this case, it's going to send a 200 response and then respond with the string hello world. We're going to go ahead and create an HTTP server and send it that handler. And then we're going to start listening on port 1337 on the localhost. So this is a little a UI I stole from this guy called Leighton Flip on GitHub. He's given a bunch of talks at JSConf and stuff like that. And he's got this really cool project called Loop that does all this stuff that you're about to see. Like you can just put in a function and hit run. It shows you what it's doing in the event loop. It's really cool. But this is my little keynote animated version of that. So just to give you an idea of what's happening in Node in the event loop with this little server. So when we bind here, server.listen, what it's actually doing is creating essentially this event listener that's going to listen for events on the socket. And when it gets an event, it's going to take this handler and add it to the callback queue. Right? So the event loop is going to run, and it's going to move that up into our call stack. And so our call stack is going to run that handler function right there and kill it off. And now it's ready to do some more stuff. But that call stack can only be running one thing at a time. It can't be running multiple things at a time. So that's basically what's happening. So let's look at what blocking actually does to that call stack when you're doing it. So we have that same function, the server here, except this time we added this fictional delay function. And imagine this is like a big synchronous function that's just going to run a bunch of stuff. It takes like 10, 20 seconds, right? So we have the same thing. Our server is going to bind the 1337. It's going to create this listener. It's going to take our handler, put it in the callback queue. It's going to run our event loop, move that up into the call stack. Now it's going to step in. It's going to hit this delay function, right? And so this is a synchronous function. It's going to take a while to run. Meanwhile, requests are coming in. Our event loop is completely blocked. It can't do anything. It can't handle requests. So right now you've essentially locked up your server running this function. Right? So it finishes, the handler gets off, now our event loop can run, start all over again. Right? So that's what they mean when they say blocking. So synchronous code blocks the event loop. Just never do that. And so what happens if we don't block it? Right? So this is a callback. We have a simple callback here called send email. And we're assuming here that send email is an async function. It just does a little bit of like network I/O. It's not a big synchronous thing. So same thing. We're going to have this bind. We're going to get our handler. The event loop is going to run. The handler is going to get up in our call stack. We're going to step into it. We hit our send email function. What that's going to do, meanwhile, 2 more requests come in. And what that's going to do is it's going to queue up this function callback here. And so it's going to queue up the callback. And then our handler gets to the end of it. It's done. So our event loop can run again. And so it's fast, right? We're never once were we sitting there blocking where the server couldn't do anything. All right, so start over again. Callback. Handler's done. Now when our event loop runs, now when we move this callback in, right? It's small, it's just going to return, and we're done. So by doing async stuff here, you see exactly kind of what's going on. And why remote queues are kind of good if you have big blocking functions, right? So normally these functions are going to take up space in your event loop and your callback queue. And that's usually not the end of the world, because libuv, the thing that kind of runs this event loop and stuff, it's It's really good at what it does. But the more work that you're doing in the event loop and the more work you're doing in that callback queue, the less you can handle. So you lose concurrency the more that you're doing in there. So by moving certain types of code into background jobs, we can do more in our web processes and we can do it faster, which means our web processes can handle more traffic, right? So now we have a little thing, like a little primer about what all this works. When should you move a function into a background job, right? Like when you start writing Node, when you start writing JavaScript on the server, you don't really sit there and like, oh, I'm going to write a background job, right? So you just write async code and then you run it and stuff starts to build up, starts to be a little bit slower. Unless you know for sure something's going to be running in the background, you usually don't start thinking background jobs in Node. So when should you refactor some of that code and move it into a background process? Obviously, if for any reason it will block the event loop, you got to get it out of there. You should probably refactor it and make it small async pieces. So remember, the smaller the pieces, the more that event loop can do. And if you don't know, there's a little note like array operations. So like each, loop, map, reduce, like all these things, those are all synchronous functions. So if you have an array of 150 things and you're going through and you're doing stuff to it, that entire thing is synchronous and you're blocking the event loop when you do that. So that's something to think about. A quick way to do that, there's a library called Async. You can use like async.each. But anytime you're working with arrays, it's really easy to not think about that and you can block the event loop. If for any reason it's going to prevent the response from returning in a timely manner, it's a great case to move out into a background process. So if you're sending an email and you're waiting for that to return before you return the response, that's a good thing that can easily be moved out. It's a common use case. If you're creating a VM, like anything that's going to take a while before it returns the response, it's a perfect use case to move into the background process. And your background processes aren't like this thing that just runs in the server. Like they can still communicate with your web front ends. There's like WebSockets and all these different things. So it's not like you're moving it out and you're completely separating it from your web process. Imagine uploading an image, right? And then you're sending it to S3. You can still send progress events to your client, which is pretty cool. So there's some Node modules to help you with this. Probably the biggest if you're coming from Ruby or something like that, Rescue. It's completely available in Node. It's called Node Rescue. The guy that maintains this works at TaskRabbit. His name is Evan Toller, I believe. He runs Action Hero.js, which is a web framework. It's got all like these jobs built in. It's pretty cool if you want to check that out. He's also given a bunch of talks on background jobs, so you can check those out. Q is another one. And this is run by, or this is a really old one, it's been around for a while, but it was created by Guillermo and TJ when they were at LearnBoost. Now it's Automatic, which is WordPress. They moved it to that GitHub repo, but it's been around for a while. I've used that one a lot. There's a few problems with clearing jobs and stuff, but it's a really good place to start.
That's TJ Holloway?
Mm-hmm. Yeah, he doesn't maintain it anymore.
Because he's doing Go now, right?
Yeah, he left Node. But,
all that drama.
There's this other one called Bull. I haven't actually used that one, but it's got some pretty good reviews. It's pretty simple to use and check out. So there's plenty of libraries you can drop into your Node modules and to do some of this stuff. Also, most queues these days are built on Redis, and Redis is really great. It's fast, it's in memory. It still syncs to disk, so you can set how often you want it to sync to the disk. It's got all these great things, exactly what a queue would want. It's got push and pop, and it's atomic. It has basically all the functions you need to run a queue. In fact, it's so popular with these that the guy who created Redis, is like Salvatore, anti-Redis on GitHub, he's creating this entire project based on Redis that simply handles background jobs and tasks and stuff. It's called DiskQ. It's not ready yet, but this is going to be probably something to keep an eye on, especially if you're interested in this kind of stuff. There's also no reason you have to use Redis. Like a traditional message queue, so if you're already in an organization and you have like probably one of these things in play, so Apache Kafka or ZeroMQ or RabbitMQ, these are really popular message queues, and the entire function is to allow process communications. So like it's really big in the microservices architecture stuff these days. like, there's no reason you have to use Redis. All these things work great for building queues on. There's probably libraries that work with all of these too that you can plug into your Node libraries. So in summary, remote queues in Node, exactly the same as anywhere else. Anytime you need to do something that's going to take a while, you can move it to a background process. And it's actually better in Node because of this event loop thing. If you're doing something like sending an email, the majority of that time is using network I/O, so it's sitting there. So in like Ruby or something where you'd have to spin up a server or a VM for each worker, we can do like 100 things on a Node worker, right? Because it's still using the event loop. As long as they're not synchronous and blocking, you can process so much data in them. And I actually have a demo that we can show this in a minute. So your workers are the same thing. They're non-blocking I/O, and you can process a lot of stuff. So the hardest part is scheduled tasks, right? So scheduled tasks are like very complicated. And a scheduled task is something that you want recurring. So that's like every day at midnight, run this function. And there's not really a good solution for this right now. You need a database-backed scheduler. So I wish I had a slide that showed kind of like how scheduling works. But so you have these background jobs that are queued up. And so like say every day at midnight, we want to process all of the accounts receivable or something and mark them as invoiced, right? So you go through and you have a scheduler that says, okay, queue up all of these jobs. The jobs are run in the background task on these workers, but that queue is the hard part. So you can't do it in process. You can't just use like a cron task, right? Because that's only going to run on one server. And if that server goes down, they're not going to run. So you want a database-backed scheduler. You want something that's persistent and says, okay, every day at midnight, run these jobs. And you have these web processes that are completely separated from your schedulers, right? So you have a lot of web processors, and you need a master that's going to go and schedule these jobs, right? You can't use a set interval because of that set interval in JavaScript. If that server goes down or it restarts, that set interval starts all over again. So someone should write one of these, right? Until then, there's this project called Agenda, which is being used. It's Mongo only, which I'm not the biggest fan of, but it works for what it does. And this allows you to say, okay, every day at midnight, go and run these jobs, right? So exactly what we want. Every day at midnight, it's going to go and it's going to queue up all the accounts. It's going to queue up those background jobs, and then it's going to process them. But yeah, so if anybody wants to write one of those, like, it's a very good project. You'd get a lot of stars on GitHub. And actually, if somebody would just fork Agenda and make it not Mongo only, like that would be great too. But all right, so I have a little demo to go through. Let's see. I guess first off, if there's any questions. Yeah.
So I'm new to the Node world, just learning it myself. With regards to scheduled tasks, though, is that really such an issue when we all have cron jobs available to us on Linux machines?
Right. So if you think about like a Heroku infrastructure, like a cloud infrastructure, right, or like even like with Docker, right, what you're talking about is these VMs, and like on Heroku or something like that, it's a web process that gets compiled. And so if you have a cron job, you can set up a cron job, but you have to tell like one of these to be a master. So like if you have that on EC2 or something, like these are ephemeral machines, they're not going to be around. And so if that machine is down, that cron task doesn't run. And so you can't really scale that out horizontally. So if you have something in your database that says, okay, run this every day at midnight, whatever one is the master can go and grab that and queue up all the tasks, and then your workers could run. If that one's down, another master could take its place. Like it just allows you to have a horizontal scaling architecture. Because you can't have that cron job run on all of them, right? Or those tasks would be run, like it would queue all those tasks for all of the VMs. So.
If you're using Redis, it would be possible to have a whole other node instance pick up those tasks and do like a multi-core thing.
Yeah.
Yeah.
Yeah. So like, I'll show you this. Like, let's see. Yeah. So. Okay, so this is Node Rescue, which is it's a demo. But here we have this is an Express server. Can everybody? Yeah. Let me see.
A little bit. A little more.
Ah. All right. So here we have, this is just a little Express server, and it requires Node Rescue and Express. It's got a config. So it's got a config here that says how to connect to my Redis. It's just a local Redis instance, and it has this job thing here, which is just a function called send email, which takes in an object that has an email key on it, and it's going to do a set timeout, so it's going to wait a second, and then console.log send email to this email address. So it'd be like simulating actually sending an email. And then we have this server here that is just going to start the Redis server, and then we have this thing down here. It's going to create a queue. So what that's going to do is going to connect to my Redis instance and start watching for things. So in this case, this is our server, and all we want to do is be able to queue things up. So we have this route here, and we're going to send 100 emails. So we're going to do this async whilst. It's going to count to 100, and for each item, it's going to increment the count, and it's going to run this function right here. So this is going to enqueue an email. So here we have, like, here, this is the name of our queue. So you could have named queues, and the benefit of that is you can have workers that process certain things. So if you're doing like video processing, you could have all the video processing done on a machine with a like high or GPU. If you had a lot of like memory intensive things, you could have it done on a machine that has a lot of memory. So you could have it named queues, then the job you want to run, and then the data you want to send. So in this case, this is doing, it's going to send an object with the key email, and our email is just going to be count underscore the number, and then @test.com. So that's going to queue it up, and then we're just going to return out the function and return res.send sending emails. So when I hit this route, it's going to queue up 100 items and return with sending emails. And so that's kind of where it gets to that diagram we had, where server hits a route, does some stuff, and we're going to queue up 100 of those, and we're going to return immediately. So if I get to a browser, I hate this full screen stuff. All right, here we go. Oh, and so this is the UI for Rescue. It's the exact same one as Ruby. It's pretty cool. I'll show it once we queue some stuff up. All right. So I'm going to hit this URL. It's just my, oh, got to start my server. So all right. So we hit this. I get this message sending emails. All right. If I look in Rescue here, refresh, I see my email queue has 100 jobs sitting there waiting. Currently, nothing is happening. So I have this other thing here called worker.js, and this is very similar to the other one. It requires Node Rescue, uses the same config, the same jobs. It says watch the email queue. It's going to call start worker. So in this case, it's just going to do rescue.worker, and it's going to connect. And so this is the thing that's actually going to process those functions. So if I start one of those, you can see it starts pulling jobs off that queue and processing them. So 3, 4, 5, and it's just running it, send email to, and so that's running our send email thing here, right? So this is running in a separate process. If any of these fail, I could set it to retry. You could have max retries, but it's completely independent of my web server. And if we look at the UI, so we see I have one worker here processing send email. I don't have any failed. I currently have one. And you can see the jobs. They're at 50 now. So it takes a long time because I only have one worker, but I could go and I could start another worker here, process them twice as fast. So now this one's processing too. I can do this on and scale it out as I needed. Hopefully this will finish in a second. So I'll show you.
Can you show that worker code again?
Yeah. And I have a GitHub repo for all this stuff, so I can put that up. But this is the actual function, and then our worker code here. Essentially, this is the only thing that like really matters. It's going to create a new rescue worker. You pass it in the config, what worker queues you want it to process, and then your job descriptions, and then the start worker is just a function here that's going to call worker.start. If this is done, okay. So that took a while with 2 workers, right? And it's not doing anything that is that intensive. The good thing about Node, like in Ruby, you'd have to have 1 VM per worker, right? There's this thing called multi-worker. Because this thing is Node, it runs on the same event loop, and this is all non-blocking code, I can spin this up and process multiple ones at once, right? So while it's waiting, I can be doing other ones. So in this case, I'm setting minimum processors to 1, max to 100, and some other config here. And so now, if I kill off these workers, and I'm going to queue up my multi-worker, okay. So now, when I hit this, it's going to send my emails. And now if I look at this, it's processing them like really fast, right? So it's processing multiple ones at once. And so that's kind of the beauty of workers and all this stuff in Node, is that you use it the same way you would in Ruby or a synchronous language, except now I can do a lot more in my workers. So it already processed 100.
Quick question.
Yeah.
Do you have a sample or like a demo of the worker process or the queue process responding back to the web client?
I don't have any sockets set up on this. It'd be pretty easy. So if you're using like Redis or like a socket store, it's the same thing. It would work the same way as if you have multiple like web process is using the sockets.
Okay.
So you have to have a socket store, and then because the request can come into this server,
Mm-hmm.
so it all has to coordinate through like a Redis instance or something like that. You could talk to that same thing in a worker process. So you emit event on a socket, same way. But yeah, I can put that together and put it in the GitHub repo. It's interesting. Let's see if there's anything else on my slide. Oh yeah, so these are the guys. This Philip Roberts here, Latent Flip. He wrote this really cool project called Loop, and he's got a bunch of videos on how the event loop works, and he explains it way better than I ever will. Let's see if there's not a README, but this is pretty cool. Check it out. And then Evan Toller is the guy I was talking about that runs Action Hero.js. It's really cool, and it's got all this stuff built in. He maintains Node Rescue. So, yeah. Any questions or?
So my question I was kind of getting at before is that like Node is inherently kind of like a single core kind of paradigm. How can we use this to kind of defeat that paradigm?
So in Node, you can always run multiple Node instances, right? To use up all your cores.
Yeah.
You can also do like the I didn't have an example of this, but you could do the like clustering stuff built into Node. But Redis, like the workers, it'll take advantage. Like what it's doing here is here. I don't really know, like, obviously my computer doesn't have 100 processors. I just copied that out of the thing. But, I mean, it's using the event loop the same way, so it can only do one thing at a time, but it can do it, it's like the non-blocking stuff. But you can scale out workers. So I could run, like, if I have 8 CPUs on here, I could run 8 workers and each one can take full advantage of a CPU.
They'll optimize accordingly. Okay.
Are you familiar with Amazon SQS and how that would relate to like using Rescue, for example?
I'm sure that there's a library to do it. The problem with that is that it's a remote, right? So if you're running inside of AWS, the latency is probably going to be pretty fast. If you're running on a server outside of that, it's hitting a network request, so that's going to be pretty slow for an actual queue. But if you're inside, like it'll be fast. I don't know of any libraries that natively do it on SQS, but it should be. If not, I mean, it should be easy to write. It's the same thing as kind of these other libraries here. If there's not one, it'd be really simple to write.
I totally agree. I'm just interested in multi-worker, for example. I ended up writing my own, and it would have been a lot nicer to use somebody else's.
You could probably copy a lot of that code and just replace the parts where it talks to Redis, because most of that is actually just running the functions, right? It's all you gotta do is pop it off the queue, and then run it. So that multi-worker is probably, I haven't actually looked into how it's implemented, but it's probably just doing like process spawning.
So I can answer the question. We actually use that as spanning. You can again install the AWS SDK, and they have the interface that you podcast does, because that's actually what we use.
But they don't provide you a worker, though.
No, we have EC2 instances that get brought up, and basically chef config that brings up node processes, and they're all monitoring those queues. But my question for you is, what sort of capacity have you worked with background jobs? Like, how long of a background process are you talking about?
What do you mean, like how long? Like how long do they run, or how long are I mean, they can run for as long as you need it to run, right?
I'm just curious, like your experience personally, like how much have you seen run?
We usually do it for network requests, so I mean the longest one's gonna take like 30 seconds, or sending emails or something like that. If you're gonna have it like a long running process, like you're gonna run into timeout issues and things like that, which you can put checks in. Like this library has checks for timeouts and it requeues it and stuff like that. But you probably, anything that's gonna run for a long time like that, you probably want something like.
I mean, the only reason I ask is some of our backups, we have people that will go and they want their data back out of the cloud, and so we allow them to export it and basically download like CSVs and the long data and everything.
Mm-hmm.
Some of those things can take like weeks to complete. So that's just curious.
I mean, the good thing about these queues is that if you could have a node like front end that's queuing these things into Redis, and then you could have like Java workers running and just popping things off the queue. Like you could have like each one of those workers could be in a completely different language.
Sure.
So you could have like a specialized like compiled code base that's going to run that.
Yeah, it's nice to see. You actually describe a pretty almost exact kind of architecture that we've developed, with like some web servers that just sort of let queue things up, and a bunch of workers just sitting there holding the queues looking for something else to do.
Yeah.
And they don't respond back through sockets, but it's really cool to see that somebody else sort of came up with the same solution.
Yeah, I mean it's a common thing, right? It's in almost all the languages. It's just in like Node, a lot of people don't tend to think of like moving stuff in the background because they have this concept that, oh, it's async, and so it's not going to block my server, so I can just do it in my web process, which is great for a lot of things, but like there's a lot of things you should just move out, and it's going to make your life a lot easier.
Yeah, where we ran into this example is very cool. Where we ran into this was exactly the email that was on the sign up for the website. So you go, you log in, you sign up for the website, the first thing it does is it sends you that confirmation email, which was all groovy when there was like 10 people signing up for the website. But when you scale that to like 1,000 people concurrently signing up for the website, you're now sitting there in a queue watching this thing spin as you're waiting for your email, which is just a horrible user experience. What we really wanted was put in your information, get back that answer as quickly as possible. Your email is on time. And then when your email comes 2, 3, 5 minutes later, whenever the hell the queue clears out, that's it. But when we did it asynchronously, just go, oh yes, async. We were like, oh, we're actually like waiting, thousands of people waiting for the sign up for your email, and you're sitting there and you're typing out. So this was like the exact example that we read, that we had to pull things out and choose for.
Yeah, it's like when you're building it in Node, you never think, oh, I'm going to move this into a background process, right? You're just sitting there and you're writing code and you just write it asynchronous, and you never kind of think about that. So it's important to think of like when you should move something out. And in development, like that email inline in the route is probably fine, but then you hit production, it's the same thing, same case, right? And imagine if that was blocking, like your server would be completely.
Yeah. We ended up moving it like everything, so like emails, Twitter, push notifications, anything that didn't require the user sitting there waiting, we just pulled out into a queue.
And there's even things like for emails that you don't really think about. So it's like when you're building that email, so you're either probably combining strings or you're running it through like an EJS or something, like that's blocking, right? So like when you're concatenating large pieces of strings and like grabbing items out, like that's all blocking the event loop. So that's important to keep in mind too.
Seeing how you work as sales and you're a developer on the ORM stack, what are your experiences using Node writing ORM and the garbage collector?
I mean, I've never specifically run into issues with the V8 garbage collector. Usually like for ORMs and stuff like that, it's all, you're just talking directly through the adapter interfaces. So it's all just network IO. It's just passing messages back and forth essentially.
So never having any issues where like memory would get clogged up and GC would cause with the stop the world phases and whatnot.
I mean, I've run into memory leaks for sure, which they're kind of really hard to track down in Node sometimes, unless you just like you take and keep snapshots and stuff like that. But I mean, for the most part, like a memory leak, you can look through the code and find it. But yeah, I haven't actually like had any problems dealing directly with garbage collection or having to like manually clear it out. Yeah, we can also like talk about sales and stuff. We have some of the sales team here if anybody's using Sales.js. Cool.
Hey Cody, do you want to show where your project is?
Oh yeah. I can tweet out a link or something too. It's on.
I posted it to the meetup comments.
Cool.
Okay, great, thanks.
Yeah. GitHub, Product Banana. It's the August Node meetup. I could put in a README of how to run it too, but there's server.js, worker.js, and multi-worker.js in here. And I can work on getting something together that does like the socket passing so that like a worker can pass a message back to the client.
Awesome. All right, man, thank you. So we've got much food left, much drinks left. You know, y'all hang out, and again, Financial Nathan, please send me an email if you've got ideas for, you know, subject matter that you want us to talk about. We'll get out there. So thank y'all.
Thanks.